In this video, I'm going to go through the topic 6 test review. Remember that you can't use a calculator for this quiz. The formulas that are given at the top, the first one's for question 1, and then the second one's for question 2. So anything else that's on here that technically is a formula, it's something that you need to know. So when I'm finding the length of the arc, I'm going to use the formula S equals R theta. However, remember that theta needs to be in radians. And so I have to convert the angle that's given to radians because it's given in degrees. So the radius is 6 feet, theta is 255. I'm just going to plug them each in and use the conversion factor too. So the radius is 6. Times the angle is 255 degrees. And then since we want it in radians, we have to multiply that by the conversion, which is times pi over 180 degrees. And so I'm going to go through and simplify the 255 over 180 and then evaluate after that. So 255 and 180, one ends in a 5, the other one ends in a 0. So I know I can at least divide them by 5. So if I divide 255 by 5, that's going to be 51. And then if I divide 180 by 5, that's going to be 36. So the 255 over 180 can reduce to 51 over 36. And then actually I can do that one more time because 51 is divisible by 3. So if I divide 51 by 3, that's 17. And then 36 divided by 3 is 12. And so since 17's prime, I know that I can't do anything else with that. Since this has gotten messy, I'm going to rewrite. So I still have the 6 from the radius times, now I have 17 pi over 12 is what 255 is. And so the last thing that I can do is I can actually reduce the 6 with the 12. And so if I divide 6 by 6, I get 1. If I divide 12 by 6, I get 2. So that means that the answer for this is 17 pi over 2 feet. So the length of the arc in the diagram is 17 pi over 2 feet. The second formula is for the second problem. So again, I used this formula for problem 1. I'm going to use the area formula for problem 2. So notice that since there's a 360, that's a clue to you that you are actually using the degree measure for this, and pi is involved in the problem. So I'm going to rewrite that equation for problem 2. Area is equal to n, which is the angle measure, divided by 360 times pi r squared. So if we plug in what we know, the radius of the circle is 20 centimeters. The angle is 210 degrees. So we've got 210 over 360 times pi times 20 squared. Again, these review problems do have kind of large numbers. Know that on your quiz or test, I'm sorry, it will not be as large. So when I have a fraction and I'm reducing and they both end in zeros or multiple zeros, the same number of zeros, remember that dividing by 10 allows us to reduce by those zeros. So 210 divided by 10 is 21, and 360 divided by 10 is 36. I can also divide 21 and 36 by 3. So if I divide 21 by 3, I get 7. If I divide 36 by 3, I get 12. And so right now we have 7 over 12 and then times pi times 20 squared. So let's evaluate that 20 squared. So right now, technically we have 7/12 times pi times 400. And so 400, I can reduce, let's just go piece by piece here. 12 might go into 400 itself, but let's start with, oh no, it's not. So we got 4. 4 goes into 12 3 times. And then 4 goes into 400 100 times. So if I divide 12 and 4 each, sorry, 12 and 400 each by 4, I've got a 3 and a 100. So then 3 doesn't go into 100. So that means that our answer is going to be 700 pi over 3. And then our units were centimeters because it's area. Remember, that means that it's square centimeters. So that answer for number 2 is 700 pi over 3 square centimeters. For question 3, we're doing what we had to do in 1 to simplify or to convert to radians. So that means that we're multiplying by the conversion factor pi over 180 degrees, because remember, those are equivalent on the unit circle. Okay, so we know on the unit circle that pi and 180 are at the same location. So for these, they again both end in 0. So 400, 180, if I divide 400 by 10, I get 40. If I divide 180 by 10, I get 18. And so then what I can do further is that 40 and 18 are both even, so I can divide them each by 2. So if I divide 18 by 2, I get 9. And if I divide 40 by 2, I get 20. So what we have now is 20 pi over 9. And 9 doesn't go into 20 and they have no common factors. So that's our answer. So 400 degrees is 20 pi over 9 radians. We can do the same thing with the 320 and the 180. So because that 320 is negative, we know our answer is going to be negative. So we just have to make sure to carry that down. So I can divide negative 320 and positive 180 by 10. And I get negative 32 and positive 18. One thing I forgot to talk about is that our degrees cancel out. That's how we know that we're converting appropriately, because the degree symbol disappears when we multiply by that conversion factor. So then we're left with 32 and 18. And again, they're even numbers, so we can divide them both by 2. So if I divide 32 by 2, I get 16, and 18 divided by 2 is 9. And so what we have left over then is negative 16 pi over 9. And again, 16 and 9 have no common factors, so that will not reduce. For number 4, we're converting backwards. So that means that we're going to multiply by the reciprocal of what we multiplied by in the previous problem. So my clue that I know I'm using the appropriate conversion factor in this one is that pi disappears and I'm left with a single degree measure. So I can see that the degree is not going to cancel here. However, for each of these, pi is going to cancel. So that's how I know that I'm using the right formula. So when I reduce this, what I want to do is be able to divide. So 12 does go into 180. So 180 divided by 12 is 15. And so if I divide 180 by 12, I get 15. So all that I have then is 5 times 15 degrees. And so that means that this is equivalent to 75 degrees. So a similar thing if I'm doing the next problem. So I already used red. So I am looking at simplifying 180 divided by 5. And so remember that 180 divided by 5 gives us 36. So I can do that because 5 goes into 180. So what I have left over then is -7 times 36 degrees. And so if I multiply 36 times 7, I get 252 degrees. Then for number 5, we are finding the missing sides of a 30, 60, 90 right triangle. So remember that when I'm looking at a 30, 60, 90 right triangle, I have a pattern with the sides that I know where all of them are in reference to the shortest side, so the side across from 30. So whatever x is, that's our a value that all the other sides are in relation to. So the side across from 60 is always a times radical 3. And the hypotenuse is always a times 2. And so this one's nice because the radical 3 is already there. So since it's a times radical 3, that lets me know that a is 9. And so that means that x is 9, which means that y is 2 times 9, which is 18. Okay, so in a 30, 60, 90 right triangle, I have to know that the shortest side is our a, and then the one across from 60, so the next largest is a times radical 3, and that the hypotenuse is a times 2. For question 6, they give us one of the trig functions and want us to find the rest. They're telling us that we're in quadrant 1 just so that we know that, remember, all of the trig functions are positive, so none of our answers should be negative for these problems. So what we're going to do is identify what we have and then find the missing sides of the triangle. So if I think about a triangle, if I have cosine, that means that I have the adjacent side and the hypotenuse. Okay. And so the adjacent side is the side next to the angle. The hypotenuse is the other side next to the angle that's across from the right angle. And so what I'm missing here is the opposite side. And so the side adjacent to theta is 5, and the side that is the hypotenuse of the triangle is 8. And so remember that if I'm looking for the opposite side, I'm using x squared plus 5 squared equals 8 squared. So we have to be careful in that the side that's by itself is always the hypotenuse. And so if I had a different trig function given like tangent, right, it would mean that I didn't have the hypotenuse. I would have the hypotenuse as my x. So it kind of depends on what you're given, how you'll end up solving this equation, whether you're going to subtract something or add something. So be careful in that this one is always the hypotenuse. So I have x squared plus 25 is 64. And so we do have to subtract 64 minus 25 to figure out what x is. So that means that x squared is 39. And I'm going to move this. Sorry, there's not much space here. So this gives us that x squared equals 39. And so x is going to be, if I think about 39, 39 is 3 times 13. Both of those numbers are prime. So that means that my value for x is just going to be the square root of 39. Okay. So the opposite side is the square root of 39. Okay. So sine, remember, is opposite over hypotenuse. And so it's going to be the square root of 39 over 8. I was going to color code, but I'm not. I'll just do different colors for each answer. Cosine was the one that was given, so obviously that one is there. We don't have to fill it in. Tangent is opposite over adjacent. And so tangent then is the square root of 39 over 5 was our adjacent side. For cosecant, secant, and cotangent, they're across from their reciprocals. So what will help you when you're doing the test is I just flipped these. So cosecant is h over o, so that means that it's 8 over the square root of 39. And so since I cannot have a square root in the denominator, I do have to rationalize this one by multiplying by radical 39. So that's going to give us 8 radical 39 over 39. Okay. Cosine and secant are the reciprocals. So since cosine was a over h, that means that secant is h over a. And so it's going to just be 8 over 5. And again, I'm just flipping the answer to the left of it. And then finally, cotangent is a over o. And so it's 5 over the square root of 39. And again, we have to rationalize because we cannot have a square root in a denominator. So if I multiply by the square root of 39 over itself, the answer for cotangent is 5 radical 39 over 39. Okay, so these 5 answers are the answers to the question. However, there is quite a bit of work that you're going to get points for. For problem 7, Adam walks 22 feet away from his house until he reaches a ladder leaning against the house, inclined at 45 degrees. So if I have a house, and then Adam walks 22 feet, and there's a ladder that's inclined at 45 degrees, what I have then is a 45, 45, 90 right triangle. And so remember that you don't have a calculator, so you aren't necessarily using SOHCAHTOA here. So if this side is 22 feet, this side is 22 feet. So that means that the height to the top of the ladder is 22 feet because it's a 45, 45, 90 right triangle. Remember that the pattern is that if those sides are A, then the ladder must be A times the square root of 2. So if it's 22 feet, that means that it's 22 times the square root of 2 feet is the length of the ladder. Question 8 is asking us to find one negative and one positive coterminal angle. So remember that if I'm in degrees, that means that I'm going to have to add and subtract 360 in order to get these answers. So what I would do is if my answer is if the problem is positive, so if I'm given 580, what I want to do first is I want to subtract first. And then I can always go back and add later if I need to. If the problem is negative, so if I'm given negative 75, I want to add 360 first, because if I need to subtract, I can go back and subtract later. So sometimes subtracting twice is going to get me my answer, or adding twice is going to get me my answer. Other times I'm going to have to do both. So it's always better to do, like if the number that's given is positive, to subtract. If the number that's given is negative, to add. So if I start with 580, I'm going to subtract 360. So 580 minus 360 is going to give me 220 degrees. So if I think about 220, that's a positive number. So that's going to be a positive coterminal angle. Since it's still positive, I have to subtract to get a negative. So I'm going to take 220 now, and I'm going to subtract 360 from that. So since 360 is bigger than 220, when I subtract 360, since I don't have a calculator, I'm going to put the 360 on top. Remember though that I'm subtracting as I do this because they're opposites, right? So I'm subtracting, but I'm keeping the sign of the larger. So 0 minus 0 is still 0. I'm going to have 4 and then 1. So that means that negative 140 degrees is a negative coterminal angle. One thing to check is that if these two numbers are between 0 and 360 or 0 and negative 360, if I ignore the negative one, they should always add to 360. So 220 plus 140 is 360. So that's a clue that these answers are probably appropriate. It only works though when your negative one is between 0 and 360 or negative 360 as well. So for that one, because I was given a positive number, I subtracted first. In this one, I'm given a negative number, so I'm actually going to add first. So again, I always stack the bigger number on top. So since I'm adding 360, I'm going to write it as 360 minus 75. Okay, so I'm adding a negative plus a positive. So when I do this, I'm going to have to borrow because I have 0 minus 5. So I'm going to take that 60 and turn it into a 50 and a 10. So 10 minus 5 is 5. And then I have the 7 with the 5. So I can just think about 35 minus 7 is 28. And so that means that 285 degrees is a positive coterminal angle. Because I have to get a negative, this didn't give me a negative answer. I'm going to have to go back and subtract 360 from the 75. So with the last problem, I built on my answer, right? But if I were to subtract from this, I would just get back to the negative 75, and that wouldn't be a coterminal angle. So what I have to do here is I have to start again, but I'm going to subtract 360 from negative 75. So remember that works like I'm adding the two negatives together. So negative 75 minus 360, I'm really adding, and my answer is going to be negative. So I get 5, 6 plus 7 is 13. So I get negative 435 as the negative coterminal angle. Okay, so again, this one doesn't work because the 75 was the one between 0 and 360, so I can't add these to check because it's the 285 plus the 75 that makes 360. The last problem on the first page is having us find the amplitude, period, and midline of the periodic function shown. So with the amplitude, remember that we're looking at the value, the distance from the midline to the maximum, or the distance of the midline to the minimum. And so it's helpful to find the midline first and then find the amplitude. So if I start with looking at the midline. So if I look at where the max is, so our maximum value is 1, and the minimum value is negative 2. And so I can see visually that there's 3 boxes across. So the midline is going to cut those 3 boxes in half. And so if I find the middle of 3, right, that means it's there's 1.5 on either side. So that means that the midline is going to go, let me draw that better, through negative 1/2, so that I have half and then 1 to the max, I have half and then 1 to the min. Okay, so remember that this line, because this is at y equals negative 1/2, that's our midline. And ultimately, the way that I can get that value, so the formula that we talked about when we did this originally, is that I add the max and the min. So this is 1 plus the -2 value for the minimum divided by 2. Okay, so I can do it either visually or remember that formula. So 1 plus -2 is -1/2 is where this midline number comes from if you want to do it using a formula. Okay, so max plus min divided by 2. Visually, we can also see the amplitude. So remember that the amplitude is the distance from the max to the midline or from the min to the midline. And so we can see visually from that, that's going to be 1.5 or 1.5. If you want to use a formula for the amplitude, it's almost the same as the midline, except we're subtracting. Okay, so it's max, which was 1, minus the min, so minus the -2 divided by 2. So when I subtract the -2, that turns into plus, so that means that I'm doing 3/2, which is where the 1.5 came from. So if you find it easier to find the max, find the min, find the middle, right? And then measure how far above the max is to the midline and how far below the minimum is to the midline. Okay, the last thing it's asking about is the period. So remember that the way that we find the period of the function, so the length of one cycle, is we start at the y-axis and we follow the pattern until it repeats. So we're looking for one cycle where I can take that, and if I could cut it out and slide it over, it would overlap with the chunk of the graph each time. So since it's hitting the y-axis at 1, right, this is a max. It's starting at a maximum. So the next time that I end up at a maximum, that should be the end of the cycle. So if I follow this down, I reach the maximum here. And so what I want to notice is that, is this the same as this was? And so we can see that it is. And so the length of the cycle is the period. So the point of starting at here is that this is 0. So it starts at 0 and it goes until 3, and then the cycle repeats. And so I could check that here from 0. Notice that this maximum happens at -3. So that means that the period of this graph is -3. Okay, so I'm looking at the x-axis to determine the length of the period as long as I start at 0 on the x-axis, at the origin, or on the y-axis. For question 10, we're using the unit circle. Remember that on the regular test, there will be a filled in unit circle printed. For the enhanced test, you'll have to fill in your the values for the unit circle to help, or use it to help you answer the question. So what you do need to know, regardless, is what part of the unit circle is represented by each trig function. So remember that sine is the y coordinate on the unit circle. So for each of these, we're going to use the y. Cosine is the x coordinate. And tangent is y divided by x. So for a lot of them, we'll just have to look at the unit circle and then our answer is shown when the angle's on the unit circle. So for angles that are not, we're going to have to add or subtract 360 if it's in degrees, or add or subtract 2 pi if it's in radians. So for sine of 660, I want to subtract 360 degrees from 660 so that I can know what angle is coterminal with 660. So 660 minus 360 is 300 degrees. So that means that to find the answer for this problem, I'm looking at 300 degrees. And the answer is the y value because it's sine. So that means that the answer to this problem is -radical 3/2. And remember that these problems, you don't get partial credit. So you're looking at the unit circle, you either know how to read it and you know which one is sine, which one is cosine, and which one, how to get tangent, or you don't. So there's not going to be like oh, they put a positive radical 3/2, so, you know, they deserve something. So 5 pi over 4 is here. Since we're talking about cosine, it's the x value. So that means that the answer for this is negative radical 2/2. So the answer for B is negative radical 2/2. Again, for something like that, I literally have no work. It is just looking at the unit circle, getting the answer. Tangent's a little more complicated because I have to do the division and simplifying. So since this is in radians, really what I have to do is add 2 pi, right? So that's a negative value. I should be adding a revolution. So technically what I'm doing here is 2 pi minus the pi over 4 in order to figure out its coterminal angle. So since the pi over 4 has a denominator and 2 pi doesn't, I want to multiply by 4/4 so that they both have that denominator of 4. So that means that 2 pi, I want to think about it as 8 pi over 4 instead, minus pi over 4. And so that means that negative pi over 4 is equivalent to 7 pi over 4. Remember that I didn't have to necessarily do that as long as I know what pi over 4 looks like positive. So if this is positive pi over 4, remember that a negative angle is just the reflection. So if I see pi over 4 here and I reflect this point, it gives me the 7 pi over 4 as well. So I'd reflect it across the x-axis to find the negative value. So either way, y is negative radical 2/2 and x is positive radical 2/2. So that means that for this one, I'm doing negative radical 2/2 over positive radical 2/2. And since that's the same value and one's negative, one's positive, the answer for this is -1. These are just for a little bit of extra practice so we can see a little bit more of what might happen. So sine of negative 240, that means that I want to add 360 to this. So I'm going to write 360 above because it's a larger number. So if I do 360 minus 240, that's going to give me 120 degrees. So if I look at 120 degrees, that's here at 2 pi over 3. The sine is the y coordinate, so the answer is radical 3/2 for D. For cosine of 11 pi over 6, 11 pi over 6 is on the unit circle. So if we look at 11 pi over 6 here, cosine is the x coordinate, so it's radical 3/2. And then our last one is tangent of 180. So if we look at 180 on the unit circle, x is -1, y is 0. So y over x is 0 over -1. And so that means that tangent is 0. So remember that if that was the -1 over 0, that would be the value that's undefined. So you have to be careful and remember how those work together. Okay, so the rest of these are graphs. So for question 11, we're graphing sine. Notice that there's only amplitude and period. There are no shifts. For question 12, we're graphing cosine. There are shifts. So for the tests, know that it could be either like where you're graphing sine with no shifts and cosine with shifts, or it could be the opposite where you're graphing a cosine function without shifts and a sine with shifts. So those might switch depending on the version that you have of the test, and then tangent, we did not shift. So tangent's going to just be a regular graph, kind of like 11. So for sine, remember that we're thinking about the pattern of the y values. So with the sine graph, our pattern is 0, then a, then 0, then -a, and then 0. And so that changes how we graph the function. When we're looking at the values, amplitude comes from the value for a. So A is 3 in this equation. So that's the value that we're using here. And then the amplitude is the absolute value of 3. And so the amplitude for this is positive 3 as well. For the period, for sine and cosine, remember that we take the B value, in this case B is 4, and we divide 2 pi by that number. So sine and cosine is always 2 pi over the B value. So in this case, that means if I reduce that, it's going to be pi over 2. So pi over 2 goes in the last x value. And then, so that means that I'll have negative pi over 2 on the last value for the negative side. And so remember that these are evenly distributed. So I'm identifying every other x value here. So I have this as kind of, that's why the graph's wider than it is tall. And so this is a full side, so I'm cutting it into equal parts. And so if I find the half the distance between pi over 2 and 0, I'm really multiplying half times pi over 2 to get this middle value. So that means that I get pi over 4. And then the value to the left of this is now between 0 and pi over 4. So equally distributed, I'm doing the same thing, and it's just building on the answer. So I'm doing half of pi over 4 then to figure out that number. And so that's pi over 8. Okay, so let me fill in the negative values. And then for the third one, remember, it's like I'm adding pi over 8. So pi over 8 plus another pi over 8 is 2 pi over 8, which gives us the pi over 4. And so then if I add 2 pi over 8 plus 1 pi over 8, I get 3 pi over 8. And so the shortcut here is I'm taking that number, pi over 8, and I'm multiplying it by 3. Okay, so every time this is building. So I figure out the period, multiply it by half to get the middle, half to get the middle again, and then to get that last one, I multiply the first one by 3. So then I have negative 3 pi over 8. So since I have no translations, I'm just going to graph the full equation and kind of finish my pattern. So since it's sine, I'm starting at 0 on the y-axis. And then my a value is 3. So at pi over 8, it's going to be at 3. Then I'm back at 0 for pi over 4. And then I'm at negative 3 for 3 pi over 8. And 0 for pi over 2. So remember that this is one cycle of the sine function. Make sure that you're graphing it with a curved line. Don't connect those with straight. It's not a zigzag. The same pattern happens on the left side. So since I started on the left of this half of the graph, I'm starting on the left at negative pi over 2. So it's still at 0. Then the next one's at positive 3, 0, negative 3. So remember that as you do the pattern, you're using kind of the x-axis as the midline. And then know that you're good as long as you have something. If you have the maximum, you should have a 0, then the minimum, then the 0, then the maximum, 0, minimum, maximum. You should never have like a maximum right next to a maximum, or a minimum right next to a minimum. So be careful with that. With the next one, we're graphing a cosine. So remember that the way that the pattern changes is it shifts over 1. So with sine, we started at 0. With cosine, we start at the a value. So then the 0, then the negative a, then the 0, then another a value. So in this case, because a is negative 2, sure, our amplitude is positive 2, but that's not the value of a. So when we do our pattern, this is a negative 2, this is a positive 2, this is a negative 2. Okay, so our pattern is going to be negative 2, 0, positive 2, 0, negative 2 again. Looking at B, since it's missing, remember that that means it's 1. So that means that the period of this is 2 pi over 1. So 2 pi is going to be the last value on our x-axis. So this one's a little bit nicer. So half of 2 pi is 1 pi. So that middle value is going to be pi. And then half of pi is pi over 2. And then remember, for this one, we're doing 3 times pi over 2. So it's going to be 3 pi over 2. Okay, so when the period is 2 pi, they end up being those quadrant angles from the unit circle. So what we're going to do for this one is when I graph the pattern for cosine, I'm only going to do one cycle, and I'm going to graph it as a dotted line. So I want to see that you graphed the original and then you moved it. So as a dotted line, I'm going to graph -2, 0, +2, 0, -2. So remember that cosine usually looks like a U. Since this is the reflection, it's going to look kind of like a hill. And so I'm only graphing that one cycle because this has an H and a K. And so I'm going to have a phase shift and a vertical shift. So looking at this, since I have x minus pi over 2, that means H is pi over 2. So that means this graph is going to go right pi over 2 units. And then the K value is 1. And so since it's positive, this is going to have a vertical shift up 1. So remember that with H, it's always the opposite sign of what in the equation because it's minus H. So that's why this was positive for H and going to the right. If it was plus pi over 2, x plus pi over 2, that would move to the left. If it was -1, that would move down. So our strategy that we use to help us make sure our amplitude's good is by highlighting our vertical shift as our midline. So since our graph is going to move up 1, if I highlight this, that shows me that I should be 2 above and 2 below and on that line when I move the points. So one thing that is a good strategy to keep your points organized that I actually forgot to talk about during notes is using a different color or using a different symbol. So since these are dots, I'm going to use X's to draw my movement. So I'm moving every point right pi over 2 and up 1. So the up one's easy because it's literally one box. The right pi over 2, remember though, I have to check where is pi over 2 on my x-axis. So since pi over 2 is 2 boxes on my x-axis, I'm going to move every point to the right 2 up 1, really. Okay, so right pi over 2 is right 2. And then up 1 is up 1. So again, if I was moving it pi, then I would move it right 4. So see how that works based on your x-axis. So I'm going to start on the left and move right pi over 2 up 1. So I'm going to put an X instead. So then I'm at pi over 2. I'm going to go right and then up. Okay, so then I'm at this point. I'm going to go right 2, up 1. Here, I'm going to go right 2, up 1. This one's off the graph, so I'm not even going to bother. So I only have 4 of my 5 points to start with, but I know how the pattern works. So since I have a minimum here, I know my next point is going to be on the midline. Okay. Since that was a minimum, I know my next point is going to be a maximum, then back on the midline, then a minimum, and then back on the midline. So I have this highlighter as a reference to let me know that I'm going up enough, down enough. Remember that every X value we use is always 2 away. So for this one, I was going either up 2, right, left 2, or down 2, left 2, depending on which part of the cycle I'm at. Right? So again, once I have a full 2 cycles graphed, I should always have a down and an up, a down and an up, never an up, up, or down, down. The final graph that we did is tangent. So remember that tangent doesn't have an amplitude because it goes on forever up and down. So looking at this graph, the A value is 3, but that doesn't give me any answers. It just helps me plot the points. For the period, B is 4, but tangent cycle is only pi long. So that means that I'm dividing pi by 4 to find the period of tangent. So the last value on the x-axis is going to be pi over 4. I still use the same method to find all the other values. So the middle value, I'm doing half of pi over 4. And so that's going to give me pi over 8. The next value, I'm going to do half of that. So half of pi over 8 is pi over 16. And then for the one that I skipped, I'm doing 3 times pi over 16. 16 and 3 don't reduce, so it's just 3 pi over 16. So then negative pi over 16, negative pi over 8, and negative 3 pi over 16. So remember that tangent doesn't look as nice as sine or cosine, and the pattern is very different. So the way that the tangent pattern works is that there's asymptotes. My suggestion is that you draw in the asymptotes first. They're always in those middle values. Okay, so the asymptotes are here in the middle of the left side, the quadrants 2 and 3, and they occur in the middle of the quadrants 1 and 4 on our graph. And so in general, we talked about the pattern being for tangent 0, A, then an asymptote, then negative A, and then 0. Okay. And so again, that's starting at the left side at the y-axis. So if I start here at 0, my A was 3, so the next point's going to be at 3. I already drew in the asymptote just because it gives me a little bit of a visual as to where, if my pattern's going okay. And then I should have a negative 3 and then a 0 again. And so these always look kind of funky because these points, I'm going from the 0 towards the asymptote. So when I graph this, I'm curving it this way and I'm curving this one this way. Okay, so that's one cycle of tangent. And then I have the same thing happening on the left side. So where I started at the y-axis, remember we always start on the other side of the negative x-axis to do the same pattern. So still 0, 3, so that one's going towards the asymptote. And then negative 3, and the 0 is already there because this lines up with the new pattern. Okay, so then this side's gonna go like that. So remember that our kind of visual clue that we're okay is that since A was positive, the slope of these curves are increasing. So it's pointing down on the left, it's pointing up on the right. So that's tangent. And that is all for the exam. So make sure that you understand how to do each of these 13 problems so that you can ensure that you're prepared for the test.